La 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 la. Myopia, 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 myopia. Near distance we can see ya, far distance we can see ya. Myopia, 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 myopia. Further correction we are using, bro. What, bro? Further correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction we are using convex lens, convex convex lens, convex lens, convex lens, hypermetropia, 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 hypermetropia. New Cartesian sign convention, new Cartesian sign convention, all distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention, all distance are measured from the pole. Distance are positive along the infinite, distance are negative opposite to infinite, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. Okay. Welcome to the Student Brand. Today we are going to discuss about human eye and colorful word. Human eye and colorful word. Human eye and colorful word. Okay, Bhattacharya. Welcome. So now you are considering human eye and colorful word. Human eye. Human eye. And human eye and colorful word. CBSE Grade 10 Physics. So, if you are taking the eye diagram, so if you are considering, so eye diagram like that I am taking like this. So here I am considering human eye. This is the human eye. Okay, so here. So this is about eye. Okay, so I am considering here. So cornea, so front layer is called cornea. So this is a cornea. So I'm taking this ciliary muscles, and here also ciliary muscles. And next one, iris, pupil, iris and pupil. So here, aqueous humor is there in between. In between cornea and islands, aqueous humor is there. In between cornea and islands, aqueous humor is there. So we'll see now. Aqueous humor. Next one here, vitreous humor will be there. And this is the optic nerve. This is the blind spot. Blind spot. And retina. This is the retina. This is the retina. I'm talking about retina. Okay, so this is about human eye. Human eye. So human eye we are discussing now. We are discussing about human eye. Okay, so I hope it is very clear to you all. So now you can check here. Now you can check. You can check here. So the frontal layer, protective layer of the human eye, the frontal layer, protective layer of the human eye is cornea. Cornea is the protective layer. Most of the refraction takes place at cornea. Most of the refraction takes place at cornea. So and I'm considering the cornea and ciliary muscles. Here also ciliary muscles. Ciliary muscles are the it can adjust the curvature of the islands. So ciliary muscles, it can adjust the curvature of the islands. Okay, so when you are seeing the nearby object and far by object, when you are seeing the nearby object and far by object, when you are seeing the nearby object and far by object, these ciliary muscles will adjust the curvature of the islands. So these ciliary muscles will adjust the curvature of the lens, so that we can able to see near distance as well as far distance object, so that we can able to see the near distance as well as far distance object. Ciliary muscles. So ciliary, see, these are the ciliary muscles. And next one, we are going to the iris. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is the dark muscular diaphragm. Iris is the dark muscular diaphragm which controls the size of the pupil. Iris is the dark muscular diaphragm which controls the size of the pupil. And people will controls and regulates the amount of light entering into the eye. People will controls and regulate the amount of light entering into the eye. People will controls and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. Okay, so hi everybody. Welcome to the class. So hello sir. Hi Twinkle. Welcome to the class. Here, light rays. See, I'm taking ciliary muscles here, and so iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris, and the people will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. And next one, eye lens. Eye lens is the crystalline lens. Eye lens is the crystalline lens. Eye lens is the crystalline lens. Whenever the light ray falls on it, it makes the light rays to fall at retina. Aqueous humor is a aqueous humor also there here. Aqueous humor is a jelly type liquid present between cornea and eye lens. Aqueous humor is a jelly type liquid present between Aqueous humor is a jelly type liquid present between cornea and eye lens. Cornea and islands. So aqueous humor is a jelly type liquid present between cornea and islands. So it gives the sufficient force and blood and nutrition to the central cornea. And islands. Lens is a crystalline lens, convex lens. Whenever the light rays are falling on it, whenever the light ray incident on it, whenever the light ray falls on it, so it will converge the light rays and make it falls at retina. Retina is a light sensitive screen. Retina is a light sensitive screen. So image will form at retina. Retina is a light sensitive screen. So their image will form. There are two light sensitive cells are there. Rods and cones. Rods help the intensity of the light. Cones help the rod sense the intensity of the light. Cone sense the color of the light. Rod sense the intensity of the light. Cone sense the color of the light. So and the next one, optic nerve. The nerves. So whatever the image is forming at retina, that will convert into electrical signals. That will convert in the form of electrical signal that will reach to the brain through optic nerve. Through optic nerve only. So whatever the image is forming at retina, so that will convert into whatever the image is forming at retina, so that will convert into electrical signal that will pass to the brain through optic nerve. Blind spot is nothing but so there won't be any image will form. So there won't be any image will form. Only dark place. Light will not reach to that point. Light will not reach to that point. Okay. So dark place will be there. Dark place is there. That is called blind spot. Okay. That is called blind spot. So this is about human eye parts and function. So please, those who are watching, please do like, share, and subscribe, and share this. Click on like button. So remaining students also, they will get to know. So important topic, human eye and colorful word I'm teaching. So click on like button, that will share to the remaining students. They will also join and listen the class. And if your friends are there, ask them to join to the class. If your friends are there, now only started the class. Ask your friends to join to the class. So important topic, human eye and colorful word I am explaining. So share this link to your friends. Ask them to join. Attend the class. Ask them to listen the class, whether it is how it is, whether it is good or bad. Let them decide later. First, ask them to join and listen the class. Share your friends this link. So and click on like button. Then so it will be shared to others also. So thank you so much. So now we'll continue. That. So here I'm considering here, cornea is a front layer, protective layer of the eye. Cornea is a front layer, protective layer of the eye. Most of the refraction takes place at cornea, and aqueous humor is a jelly type liquid present between cornea and eye lens. Here it provides sufficient blood and nutrition to the central cornea, and iris is a dark muscular diaphragm. Iris is a Soham. Share to your friends, Soham. So share this link in YouTube, and ask your friends to join. Let them know. So there also. Okay. Thank you so much. Here, iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm, which controls the amount of light, which controls the size of the pupil, which controls the size of the pupil. People will control the amount of light entering into the eye. People will control the amount of light entering into the eye. People will control the amount of light entering into the eye. Eye lens is a crystalline lens, convex lens. Eye lens is a crystalline lens, convex lens. So so when light falls on it, so this is the eye lens. So I'm taking the eye lens. So eye lens. Eye lens is the crystalline lens, convex lens. Whenever light falls on it, it will converge the light rays and make it falls at retina. Vitreous humor is a jelly type liquid present between vitreous humor is a jelly type liquid present between eye lens and retina, eye lens and retina, eye lens and retina. So it provides a force and pressure to the eye, force and pressure to the eye. So force and pressure to the eye to maintain that shape. And retina is a retina is a light sensitive screen. So where image will form, so what type of image will form? Inverted and real image will form. Inverted and real image will form at retina. So there are two types of light sensitive cells are there: rods and cones. Rod sense the intensity of the light, cone sense the color of the light. Rod sense the intensity of the light, cone sense the color of the light. Optic nerve is the nervous. Optic nerves are the nerves. Okay. So send the electrical signals to the brain, which sends electrical signals to the brain. Okay, so this is one of the teaching aid. So you can watch my videos. One check YouTube videos, all the videos of mine. You can go to the playlist, then you will get to know. So not only this class, so remaining all classes, different every day, different costumes I'm wearing. So this is my teaching aid. Okay, so one of the teaching. It is a part of the teaching. So I'm considering here this optic now. I am talking. Chidam, just check once. What are you talking about? I'm talking about human eye, parts and function. CBSE grade 10, CBSE grade 10 physics, CBSE grade 10 physics, human eye in colorful word, CBSE grade 10 physics. Okay, so this is about, I'm talking about human eye. Vitreous humor is a jelly type liquid present between vitreous humor is a jelly type liquid present between yeah. So like that, every day different costumes. Okay, Chidam. So here I'm taking the difference between lens and retina. What is similar? Retina is the light sensitive screen. Okay. So image will form. What type of image will form? Real and inverted image will form, that will convert into electrical signal that will pass to the brain. Optic nerve is the nerve. So through this, the information will send to the brain. Normally, whatever we are seeing, that is 2D image. Whatever we are seeing, that is a 2D image. Whatever we are seeing, that 2D image, the after reaching to the brain will give the additional information. Why do you repeat same? Just for remembering sake, at the same time you can recall. Students are coming and going, right? So those are saying, so listening, but so continuously coming and going, they may not understand what I'm teaching. That's why I'm just repeating one or two times. That's enough. Okay, so I'm considering here blind spot already completed. Like say retina, there are two light sensitive cells are there. At retina, there are two light sensitive cells are there. Rods and cones. rods and cones. Rod sense the intensity of the, cone sense the color of the light. Rod sense the intensity of light and cone sense the color of the light. Okay. So if more rods and cones are present at retina, if more rods and cones are present at retina, if more rods and cones are present at retina, okay, so that point is called yellow spot. That point is called yellow spot. I hope it is very clear to you all. So this is about what is this? Human eye parts and function. So human eye parts and function. Next, we are going to the power of accommodation. Power of accommodation is nothing but ability of the eyelens to adjust its focal length. Power of accommodation is nothing but ability of the eyelens to adjust the focal length. When you are seeing the nearby object and far object, when you are seeing the nearby object and far object, okay. So based on that one, based on that and far object, Krishna, okay. Hi, Krishna. Welcome to the class. So when you're seeing the nearby object and far object, okay. So they when you're seeing the nearby object or far object, okay. So lens, that is nothing but if you're taking, sir, 1 minute, just 1 minute. So just 1 second. Sorry for the interruption. Okay, so sorry for it. So welcome to the class again. So here I'm considering here. So this is about water shimmer, jelly type liquid is present here. Jelly type liquid is present at the entire this region, entire liquid is present. That is a water shimmer. So retina at retina. So on this point retina. So we can see at retina. So there are two light sensitive cells are there, rods and cones. There are two light sensitive cells are there, rods and cones. The intensity of the light and cone sense the color of the light. And here optic nerves, whatever the image is forming at retina, that will pass to the brain through optic nerve. Blind spot, no image will form. That is about human eye parts and function. Next one we are going to the one more. Myopia, power of accommodation we are discussing. Power of accommodation is nothing but ability of the eyelids to allow the light inside of it. Ability of the eyelids to adjust focal length. Ability of the eyelids to adjust its focal length. Ability of the eyelids to adjust its focal length to allow the light inside of it is called power of accommodation. Ability of the eyelids to adjust its focal length. Ability of the eyelids to adjust its focal length. Ability of the eyelids to adjust its focal length. Okay. So to allow the light inside of it is called power of accommodation. So ciliary muscles will adjust the convex lens focal length, convex lens curvature at the same time. So to see the nearby object or far by object, nearby object or far by object, nearby object or far object. Okay, according to that we can able to see the far distance object and near distance object. Okay, so that is about power of accommodation. Power of accommodation. Now we are going to the myopia. Myopia is nothing but actually these are refractive defects. These are the refractive defects. What are the refractive defects? Refractive defects are nothing but so when light falls on it, when light falls on the light falls on the lens, when light falls on that, what happens? When light falls on the lens, what happens? So the light ray should refract. The light ray should refract. When it is refracting only, then the image will form. If the light rays refract only, image will form. If the light rays are not refracting properly, what happens? If the light rays are not refracting properly, what happens? So what happens? What happens? So those image will not form. Image will not form. Image will not form. Okay. So because of that reason, we can't able to see sometimes nearby object and sometimes we can't able to see far distance object. Far distance object. Far distance object. Far distance object. Right? Yes. So now we are going to discuss about myopia. What is myopia? How it will be arising? So what is the cause? How to rectify that one? So everything we'll discuss. Myopia is nothing but the person. So the person can't able to see. The person can't able to see the near distance. He can see person can't able to see the far distance object. The person can able to see near distance object, he can't able to see the far distance object. The person can't able to see the near distance far distance object, but he can see the near distance object. Myopia is nothing but the person can able to see near distance object, but he can't see the far distance object. Okay, myopia, short word. Myopia, short word. He can see near distance. That is the reason he can see near distance. Far distance object he can't see. Okay, so in between that, 2 points are there. 2 points are there. Those are near point and far point. Near point is nothing but so the minimum distance up to which the person can able to see clearly the object, that is called near point. So minimum distance up to which the person can able to see the object clearly without any strain or pain. A healthy person, a normal person, so near point of a healthy or normal person is 25 centimeter. 25 centimeter. So for a healthy person, normal person, near point is 25 centimeter. 25 centimeter. For far point of normal person is infinity. Infinity. For far point of normal person is infinity, because the maximum distance up to which the person can able to see clearly without any strain, the maximum distance up to which the person can able to see clearly without any strain is called far point. Near point means the minimum distance up to which the person can able to see clearly without any strain is called near point. Far point is nothing but maximum distance up to which the person can able to see the object. So maximum distance is infinity, minimum distance is 25 centimeter. Okay, so the myopic person can able to see near distance object, so 25 around like that. Okay, can't able to see the infinity point, but he can't able to see the infinity point. How can we rectify? How can we correct this defect? How can we rectify and how can we correct this defect? By using concave lens. By using concave lens, we can correct this defect. So now let me draw the diagram. So we can draw the diagram. Okay, how to draw the diagram? We'll see. So I'm taking. So here a myopic person. So I'm taking a myopic person here. So here. So you can see the near distance. So 25 centimeter and infinity. So I already said the near point. 25 centimeter is the near point. So far point is infinity. Far point is infinity. Generally for any person, far point is infinity. Up to maximum distance, healthy person, especially healthy person can able to see is so to infinity, infinity. So 25 centimeter is the 25 centimeter is the 25 centimeter is the near point, near point, near point, near point, near point, near point, right? Yes. So now we are going to discuss about. Now we are going to discuss about. See here we can see this point already said. We can't see this point, but between 25 to infinity you can see right somewhere. So far point of myopic person. So as you see, so 25 centimeter he can see, infinity he can't see. 25 centimeter he can see, right? Infinity he can't see. But between 25 to infinity, between somewhere he can see, right? Between somewhere he can see, right? Yes or no? So that point is the far point of myopia. Far point of myopic eye. 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 Right? Far point of myopic eye. Right? Yes or no? Now, if you draw, see, I already said this point you can see. This point you can see. We can't see this point. And correction is this only. We have to correct. So to correct only we can able to see the far distance object, right? For correction, after correction only we can see the far distance object. If you didn't correct that defect, so we can't able to see the far distance object. Now how to correct and how to do it, we'll see now. I am taking here. I am taking here. So like this. Okay, done. So this is the far point of myopic eye. Far point of myopic eye. So here you can observe. Yeah, I am drawing the diagram. That's why I am not talking. And in heart, hi. So Saurav, welcome to the class. Now you can see. Now you can see. Observe. So this is the far point of myopic eye. 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 So far point of myopic eye. Okay. Now I am taking here. Now I am considering here. When the light ray is coming from infinity, when the light ray is, see, as I said, so this is the 25 centimeter. 25 centimeter you can see. So myopia is nothing but the person can able to see the near distance, but he can't see the far distance object. But he can't see the far distance object. The person can able to see near distance object, but he can't see the far distance object. Yes or no? Yes. So here he can see this point, but he can't see this point. Between 25 to infinity, he can see somewhere. Between 25 to infinity, he can see somewhere. So that point I am drawing here. That point I am drawing here. Observe carefully. That point I am drawing. So if you are drawing like this, so it should meet at retina. The light rays will meet at retina. So I am taking here. So one light I am taking here. Another light I am taking here. Those light rays are meeting at retina. So here I am considering here. Okay. So like this. So here far point of myopic eye. If the light rays are coming from infinity, what happens? So as I said, if the light rays are coming from this point, but he can't see, as I said, he can't see this point, right? He can't see this point. But he can see 25 centimeter. He can't see this point. If the light rays are coming from infinity, what happens? We'll see now. Okay. So I'm taking the light rays. So light rays are coming from infinity like this. So this is a far point. So actually this dotted line represent. So light rays are coming from infinity, I said, right? Light rays are coming from infinity. So this dotted line represent. Light rays are coming from infinity. So the image will form here. Actually, we have to use single line. Okay, so I'm considering here thick line I took. So here near point, far point. If the light rays are coming, actually it should meet at retina. If the light rays are meeting at retina, as I see far point of myopic eye, means you can see, as I said, 25 you can see, infinity you can't see, but between 25 to infinity you can see. Between 25 to infinity, you can see this point. He can see this point, I said, no? He can see this point, I said, right? So that's why I'm taking, so this is a far point of myopic eye. Suppose if it is light rays are coming from infinity. If the light rays are coming from infinity, what happens? Where the light rays will meet? How it will meet? So now we will discuss. So here, as I said, if the light rays are coming from this point, light rays will meet in front of the retina. That's why we can't able to see this point. So this is about myopic eye. Okay, so what lens will use? So I'll show you the lens. So we can use concave lens. Yes or no? We can use concave lens. So we can use concave lens to correct the defect of myopia. This is a concave lens. So this is a concave lens. Okay. So we can use concave lens to correct the defect of hypermetropia. Sorry, myopia. We will correct defect of myopia by using concave lens. So we'll draw the concave lens now. I'm drawing the concave lens. here. So I'm drawing the concave lens. Okay, so observe here. Observe. So I'm taking the concave lens. Concave lens. So this is the near point and this is a far point. If the light rays are coming from far, so how it will happen? So I'm taking here, you see. Okay, so light rays are coming from this point. La 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 la. Near point, far point, light rays are coming from this point. So after that it will be diverge because it's a diverging lens. After that again it will be convergent, meet at retina, retina. So if you are extending these light rays, if you are extending these light rays, so here, so I'm considering the light rays are coming from, see this far point. So you can observe on this far point only the light rays, the virtual image should meet. Okay. So whatever we are drawing the extended light rays by using of concave lens. This is a concave lens. This is a convex lens. Inside is convex concave lens. Outside is concave lens. So this is a correction of myopic eye. Simply we can say myopia. Okay, so once again we will discuss about it. Once again we will discuss about it. Listen, observe carefully here. Observe carefully here. Okay, so here you can observe. Myopia means the person can able to see near distance object. The person can able to see near distance. He can't see the far distance object. Point number one. Myopia means the person can able to see near distance. He can't able to see the far distance object. But between 25 to infinity, somewhere else he can see. Now somewhere else he can see. Between 25 to infinity, somewhere else he can see. That is a far point of myopic eye. Far point of myopic eye. So those light rays will meet at retina. Next one, myopic eye. If the light rays are coming from infinity, where light rays will meet? Light rays will meet in front of the retina. So if light rays are coming from infinity will meet in front of the retina, right? What lens will use to correct this defect? We will use concave lens. To correct the defect of myopia. So this is a correction diagram. So once you look into the diagram, now next we'll go to the hypermetropia. So now next I'll explain about hypermetropia. Okay. Okay. So now welcome to the class. Now welcome to the class. Now you see, now we are discussing about hypermetropia. Hypermetropia. Let's start hypermetropia. Okay. So we'll see now. Hypermetropia is nothing but the person can able to see a far distance object. He can't able to see the near distance object. So here I am taking here a person. So this is a person. So the person can able to see the, so 25 centimeter he can't see, but infinity he can see. 25 centimeter he can't see, in infinity he can see. But between 25 to infinity somewhere he can see. But between 25 to infinity somewhere he can see. Okay. Point of hypermetropic person. Near point of hypermetropic person. Okay. So n dash I'm taking. So n dash I'm considering. Already near point we are discussing, right? Near point is n. Near point is n. So that's why that point I am considering n dash. N dash. Okay. Dash I'm taking this the n dash. This n dash. The person can able to see. The person can able to see far distance object. The person can able to see far distance object, but he can't able to see near. Person can able to see far distance, but he can't able to see near. But between 25 to infinity, between 25 to infinity, somewhere he can see. Somewhere between that point he can. Draw the diagram. Now we'll draw the diagram. Hypermetropia. 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 Far distance we can see. Far distance we can see. Near distance we can see. We can see. We can see. Hypermetropia. 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 Far distance. Far distance we can see. Near distance we can see. Hypermetropia. 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 Far distance we can see. Near distance we can see. Hypermetropia. Hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens, hypermetropia, hypermetropia, convex lens, convex lens, hypermetropia. Hypermetropia, convex lens, convex lens, hypermetropia, hypermetropia, convex lens, convex lens. So I'm taking the convex lens. So here the letters are coming from n dash, n dash. You can see this point. You can see this point. hypermetropia. Near point of hypermetropic eye. Near point hypermetropia. 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 Far a distance we can see. Near distance we can see. Hypermetropia. Near point of hypermetropic eye. Next one. Next one. Ah, ah, la 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 do 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 dun da 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 la 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 hypermetropia, hypermetropia. For that correction, we are using convex lens, La 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 la. Ah, So here you can observe, light rays are coming from near point. If the light rays, as I said, he can't see this point, 25 centimeter, he can't see. But he can see far point. If the light rays are coming from 25 centimeter, what happens? Because if the light rays are coming from 25 centimeter, so light rays will meet beyond retina, where he can't able to see, because light rays are meeting beyond retina. Light rays are meeting beyond retina. So actually you can see, if the light rays are coming from infinity, you can see. Light rays are coming from n dash also you can see. But the point is, if the light rays are coming from 25 centimeter, light rays are coming from 25 centimeter, light rays are coming from 25 centimeter. Those will not meet at retina. Those will not meet at retina. Those light rays will meet beyond retina. Those light rays will meet beyond retina. Beyond retina. So how to correct this defect? How to correct this defect? By using convex lens. By using what lens? Na 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 tan 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 Dun 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 dun. Da, 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 da. What lens? What lens will use? What lens will use to correct the defect of hypermetropia? Dun 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 dun. Convex lens. Convex lens. Dun dun dun. Convex lens. What lens will use to correct the defect of hypermetropia? What lens will use to correct the defect of hypermetropia? Convex lens. What lens? Convex lens. What lens? Convex lens. What lens? Convex lens. Convex lens. Right? So we'll use convex lens to correct the defect of hypermetropia. 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 hypermetropia, 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 hypermetropia. So I'm taking the convex lens. So this is a near point. N dash. N dash. N dash. N dash. Come on, N dash. So lens, what lens? Come on. What lens we are using? What lens we are using? What lens we are using? Convex lens. Convex lens. Convex lens. I am taking convex lens. 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 I am taking convex lens. Convex lens. Convex lens. Convex lens, convex lens, convex lens, convex lens. So after refraction, the light rays will meet at retina. Light rays will meet at retina. Low light rays will meet at retina. So this is N. Light rays, if our light rays are coming from infinity, light rays are coming from 25 centimeter. He can't see. Light rays will meet beyond retina. Beyond retina. He can see light rays are coming from infinity. At the same time, light rays are coming from N dash. N dash also he can see. He can see at this point also. But the point is, if the light rays are coming from 25 centimeter, where image will form? Beyond retina. How to correct this effect? By using convex lens. By using convex lens. I am taking convex lens. So if you are extending these light rays, turn 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 Okay, so here you can observe. Here you can observe. What is this? 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 Hypermetropic eye. Hypermetropic eye. Come on. Hypermetropic eye. Hypermetropic eye. Hypermetropic eye. Hypermetropic eye. What is this? What is the diagram? What is this? This diagram. Correction of hypermetropia. Correction of hypermetropic eye. Come on. Hypermetropic eye. Understood or not? So once again, the light rays are coming from 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 infinity, you can see. Light rays are coming from infinity, you can see. Light rays are coming from N dash other than 25, but he can't see the light. If the light rays are coming from 25 centimeter, he can't see. If the light rays are coming from 25 centimeter, he can't see. But light rays are coming from, so between 25 to infinity you can see. Between 25 to infinity you can see. Between 25 to infinity you can see. So that is N dash. N dash is the near point of hypermetropic eye. 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 Hypermetropic. Near point of hypermetropic eye. 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 Understood? Yes. Now we can see near point of hypermetropic eye, hypermetropic eye, correction of hypermetropic eye, correction of hypermetropic eye, near point of hypermetropic eye, hypermetropic eye, correction of hypermetropic eye. I hope it is very clear. I hope it is very clear. Once you can observe, once you can observe, once you can observe, once you can observe, once you can observe. So if the light rays are coming from infinity, if the light rays are coming from infinity, he can see. If the light rays are coming from infinity, he can't see. This is the defect. So if the light rays are meeting beyond retina, so N dash, N dash, N dash, N dash. As I said, if the light rays are coming from N dash, that only. Okay, 25 can't see. So how to correct? By using convex lens. By using convex lens. Convex lens is there. Convex lens is there. Convex lens is there. So we can correct the defect of Hypermetropia, hypermetropia, tan 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 tan, hypermetropia, hypermetropia. We are correcting hypermetropia by using convex lens. By using convex lens. Convex lens. Yes or no? Now we are going to the next one. We are going to the next one. Hypermetropia, hypermetropia, myopia, 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 myopia. Near distance we can see myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens, hypermetropia, hypermetropia. Hypermetropia, hypermetropia, hypermetropia. For that correction, for that correction, for that correction, we are using convex lens, convex lens, convex lens, convex lens, hypermetropia, 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 convex lens, convex lens, myopia, myopia, concave lens, concave lens. I hope it is completed. Myopia and hypermetropia. Next one, we are going to the uh, light passes through the prism. Light passes through the prism. Light passes through the prism. Come on, light passes through the prism. What happens if the light ray is passing through the prism? What happens if the light ray is passing through the prism? What happens? Refraction takes place. Refraction takes place. How it will see. So I'm taking the prism like this. I'm taking the prism. Okay, so I'm taking here. So one light I'm considering here. Light ray. So this is the incident ray. Incident ray. So we are extending this incident ray. Incident ray. We are extending this incident ray. The splitting of white light into seven colors is known as dispersion. The splitting of white light into seven colors is known as dispersion. The splitting of white light into seven colors is known as dispersion. Dispersion. Dispersion is nothing but splitting of white light into seven colors. Splitting of white light into seven colors is known as dispersion. Dispersion. Once a light ray passes through the prism, it split into seven colors. What are those? 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 Violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. What are the seven colors? What are the seven colors are forming on the screen? Violet, indigo, blue, green, yellow, orange, red. Yes. Whip GR, violet, indigo, blue, green, yellow, orange, red. These are the seven colors will form on the screen. These are the seven colors will form on the screen. These are the seven colors will form on the screen. Violet, indigo, blue, green, yellow, orange, red. So how to draw the diagram? Now you see, I am taking here one light I'm taking here, another light I'm considering here, like this. So like this and like that and like that. Violet 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Seven colors. Seven colors are forming. Those are violet, indigo, blue, green, yellow, orange, red. These are the seven colors forming on the screen. On the screen. Yes or no? Yes or no? Yes or no? Yes. See that. I am taking here. One lighter I am taking here. One, two, three, four, five, six, seven colors, seven colors, seven colors. When light ray passes through the prism, how many colors it is forming? Seven colors. What are those? Violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange. Red I'm taking here. What is the phenomena of dispersion? Splitting of white light into seven colors. Splitting of white light into is known as dispersion. Splitting a white light into constant colors is known as, so splitting a white light into constant colors is known as dispersion. 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 One I am taking, 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 one I am taking. Yeah, 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 yeah. Violet, indigo, blue, green, yellow, orange, red. So there are 2 points. Point number one. Dispersion. Point number one. Dispersion. Point number two. Point number two. Spectrum. 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 What is the dispersion? Splitting a white light into seven colors. It's constant color. Splitting a white light into seven colors. Its constant colors is known as dispersion. 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 Dispersion, dispersion, dispersion. Those seven colors will form like a band on the screen. Those seven colors will form like a band on the screen is called spectrum. 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 If the light rays are forming on the screen, those are called spectrum. Splitting a white light into seven colors is known as, splitting a white light into seven colors is known as dispersion. So when light ray passes through the, because of refractive index, because of refractive index, because of the wavelength, because of the refraction, so because of the refractive index, because of the wavelength, so based on the deviation, the light ray will bend towards the normal line. Violet it will bend the most, red light will bend least. That is the reason bottom is yellow, top is at red. Bottom is at yellow, top at the red. Top at the red. Yes or no? Yes or no? Yes or no? Come on. So we are going to the next one. This is about dispersion and spectrum. Now we are going to the recombination of spectrum light. Recombination of spectrum light. Recombination of spectrum of light. Recombination of spectrum light. Recombination of spectrum light. Recombination of spectrum light. Okay. So what is the recombination of spectrum light? Recombination of spectrum. Come on, come on, come on. Recombination, 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 recombination. Newton, what he did, Newton, he sent the white light. He sent the white light through the prism. Newton, he sent the white light through the prism. So seven colors form. Yes or no? Seven colors we form. That is spectrum. We discussed seven colors, dispersion, spectrum. But again, you want to split the colors. What happened? He placed again prism. He placed again prism. But those colors are not furtherly. It won't split further. That's why what he did. No, he placed in inverted position. Ah, yes. Normally he placed one prism. Okay, so again you want to split the colors. See, place the prism. Yes. Again you want to split the colors, so you place the prism. But no colors, no colors, no colors. After that, he placed the inverted prism. Yes, inverted prism. You know, he placed the inverted prism. What happens? What happens? Those colors are combined. Those colors are combined and form white light. Yes. Now I will draw the diagram. Okay. Recombination of spectrum of white light. Recombination of spectrum of white light. Are you listening or not? Recombination of spectrum of white light. Recombination of recombination of spectrum of white light. Come on. So I'm taking here this prism, this is a prism, this is a prism, prism. So he placed inverted prism. He placed that inverted prism besides of the first prism. This is the inverted prism. He placed besides of that. Besides of that he placed. Besides of that he placed. Now you see. So I'm taking here. This is the okay. So you have to send white light. Okay. You have to send white light. You have to send white light. Okay. When you are sending the white light through the prism, it's split into 7 colors. Here, you have to draw only 2 light rays. You should not draw 7 light rays. We have to draw only 2 light rays. Yes, violet red enough. Violet red enough. Not required all 7 colors. Violet red, if you draw, that's enough. After that, okay, see you know. I'm taking. What light red? White light. What light red? White light. Yes. So I'm taking here. Yes or no? I sent white light through. I sent white light through prism. 1 light. So it's split in 7 colors. So here the point is it should not okay maybe you can take but little fine. So I sent so what colors 7 colors this is white light white light white light this here also outcome also white light the outcome also white light white light here. So this is white light and red color. This is white light and red color. Yes or no? This is the prism one. This is the prism one. This is prism two. Prism two. When white light passes through the prism, it's split into 7 colors. It's split into 7 colors. Okay? Split into 7 colors. After that, again it passes. Those light rays will pass through the another prism, another prism, another prism. So we are getting white light. We are getting white light. Yes or no? We are getting white light. Yes. Yes. So this is about a recombination of spectrum white light. Recombination of spectrum white light. Come on. Right. Yes or no? Yes or no? You can observe. When the light ray passes through the, when the white light passes through the prism, white light passes through the prism, it's split into 7 colors. After that, again, we sent to the one more prism. So those colors combined and we got it white light. What light ray we got? White light ray. So how we have to place the second prism? How we have to place the second prism? Second prism must be placed in inverted position. Second prism must be placed in inverted position. Then only we will get the white light. Yes or no? We'll get white light. Otherwise, we won't get it. We won't get it. Yes or no? Keep this one in mind. So, keep this one in mind. This is Siva sir. My channel name is Student Dibran. Chalo. Then, we'll go to the water droplet, rainbow formation. Actually, related to this one more song I created. So, dispersion, 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 splitting a white light into seven colors. Dispersion, 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 splitting a white light into seven colors. Learn with me, speak with me, and sing with me. Dispersion, 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 splitting a white light into seven colors is known as dispersion. The band of colors is known as spectrum. Spectrum, refraction of light takes place by the atmosphere, is known as atmospheric refraction. Re-emission of light in different direction with a different intensity is called scattering of light. It's called scattering of light. Dispersion, dispersion, dispersion. Dis Learn with me, sing with me, learn with me, sing with me. Dispersion, dispersion, dispersion. Dispersion, 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 splitting a white light into seven colors is known as dispersion. Band of colors is known as spectrum. Refraction of light takes place by the atmosphere is known as atmospheric refraction. Atmospheric refraction, the re-emission of light in different direction with a different intensity is called scattering of light, scattering of light, dispersion, 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 splitting a white light into seven colors, splitting a white light into seven colors is known as dispersion. The band of colors is known as spectrum. Refraction of light takes place in the atmosphere is known as atmospheric refraction. The process of re-emission of light in different directions with different intensity is called scattering of light. Scattering of light, scattering of light, dispersion, dispersion, dispersion. Come on, dispersion, dispersion, dispersion. Splitting a white light into seven colors. Splitting a white light into seven colors. Splitting a white light into seven colors. So like that. Okay, so it happens. So next one, we are going to the water droplet. Refraction through water droplet I'm taking here. So here I'm considering. Wow, very nice. So I hope almost circle. Right? So when light ray is passing, when the light ray is passing here, when light ray is passing like this. So actually I wrote this song, so on it there are a few songs, few more songs I did. Dun, 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 dun. Dun, 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 dun. Dispersion, 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 dispersion. What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection, refraction, dispersion, internal reflection, refraction, dispersion, internal reflection, diffraction, dispersion, internal reflection. So if the light ray is passing, so here I'm considering here, and I'm considering here. Okay, so incident ray, refracted ray. Then I'm considering like this, like this, like this, like this. Okay, so this is the white light ray, 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 white light, white light, white light. So it's split into seven colors, split into seven colors, violet and red, violet and red, violet and red, violet and red. Okay, so in the sky, so we can able to see we can see, so in the sky, rainbow, we can get to the rainbow. So what is the phenomenon involved in the formation of rainbow? What is the phenomenon involved in the, I want to know the phenomena involved in the formation of rainbow. I want to know the phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Okay, so come on, you can see, come on, you can see, come on, you can see. So here I'm considering, so here whenever the light ray passing from one medium to another medium, this is the air and this is the water droplet. Water is that, so complete water drop, water drop. So refraction takes place, then dispersion takes place, then internal reflection takes place. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Say with me, sing with me, learn with me. Say with me, learn with me, sing with me. Dispersion. Come on. Say with me, learn with me, sing with me. Dispersion, dispersion, dispersion. Splitting a white light into seven colors is known as dispersion. The band of colors is forming on the screen is known as spectrum. Spectrum. Atmospheric refraction takes place in the atmosphere is known as atmospheric refraction. Atmospheric refraction, the process of re-emission of light in all directions with a different intensity is called, the process of re-emission of light in all directions with a different intensity is called scattering of light. What is the phenomenon involved in the formation of rainbow? Refraction, dispersion, refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Come on. So the phenomenon involved in the formation of rainbow, rainbow formation by water drop, rainbow, rainbow, rainbow formation, rainbow formation by water drop. Dispersion. Okay, so keep this one mind. That is about dispersion. So that's about water droplet, and a few more points are there. That is about atmospheric refraction. As I said, atmospheric refraction means the refraction of light takes place in the atmosphere. Refraction of light takes place in the atmosphere is called atmospheric refraction. Refraction of light takes place in the atmosphere is called atmospheric refraction. Refraction of light takes place in the atmosphere is called atmospheric refraction. Okay, so example, normally, so you're standing here, so fire is there, your friend is standing another side of the fire, you are weaving through that, you are weaving through that. What happens if you are seeing through that? So your friend image is appears flickering. If your image is appears flickering, blinking, what is the reason? So hotter air act as a rarer medium, cold air act as a denser medium. So that I will draw in the format of diagram. Come on, so we'll see. So actually when light passes, from air to water, so refraction takes place, seven colors. The total light will be internally reflection takes place. So then we will see outcome as a white light ray. Sorry, outlight as a rainbow. Outlight as a rainbow. Outlight as a rainbow. Outlight as a rainbow. So what is the primary? Okay. So now we can see. Now we can see. Now we can see. Mm, 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 Okay, next we are going to the next one. Next one. Next one is about atmosphere positions. Atmospheric positions. So when the object is when the light ray incident on the sun from the sun. Okay, so advanced sunrise and delayed sunset we'll discuss next. Okay, so next shall we go to the next one? Light rays should pass. Light rays see incidenting on the water droplet. Okay, so then refraction, dispersion, internal reflection. Now we can see, we can go with the one more. So I'm considering this earth. This is the earth. This earth. Earth I'm taking. Earth. So this advanced sunrise and delayed sunset. So here I'm taking the origin here. This is the origin. I'm taking this origin, So below I'm taking the sun I'm considering here. This is the sun. This is the sun. Okay. So when the light rays coming from the sun, so if the light rays are coming from the sun, so those light rays will when it is entering to the atmosphere, 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 entering through the atmosphere, like this. Okay. So when it is entering through the atmosphere, what happens? I'm standing here. So this is the point. When it is entering, refraction takes place. When it is entering through atmosphere, refraction takes place. Okay. So below the origin only we can see. So here I'm consider below you can take. So the sun appears here. The sun position appears here. Actually, this is the apparent position of the sun. Apparent position of the sun. Apparent. Apparent position of the sun, and this is the real position of the sun. Actually, this is the real position of the sun. Okay, real position of the sun, apparent position of the sun. Actually, what happens? So from the light rays are coming from the sun. Whenever it enters to the atmosphere, light rays will bend. So we can see above the origin. Sun push appears above the origin, but actually due to atmospheric refraction only we can see. This diagram. We can see. So we can take actually from here also we can take through the atmosphere. So like this. So we can draw the better diagram. Okay, down you can also take. Yes. So now I'm considering one more. Okay, so next one we'll discuss about one more atmosphere, where light rays passing from the sun, it we can see. So related to colors, the re-emission of light. So what is the condition for scattering of light? Normally, if you are taking scattering of light, so wavelength we have to discuss. Wavelength I'm discussing. Wavelength. Okay. So this the crust trough. The distance between two consecutive crust is called wavelength. The distance between two consecutive crust is called wavelength. The distance between two consecutive trough is called wavelength. The distance between two consecutive trough is called wavelength. Okay. So if the light ray is coming, so here is the particle. The particle size is comparable to the wavelength of the light. Whatever the light is coming and incidentting on the particle, if the particle size is comparable to the wavelength of light, the particles is comparable to the wavelength of the light. The particle size is, so whatever the light is incidenting on it, this particle size is comparable to the wavelength of light. So like this is the wavelength in maximum view. Normally if you are taking this incident ray, this is a particle. Okay, this is incident ray, this is a particle. So this particle is comparable to the wavelength of the light. So then what happens, those particle will absorb the light, and re-emit in all directions. That particle will absorb the light and re-emit in all directions with a different intensity, re-emit in all directions with a different intensity. That is called scattering of light. The condition is the particle size is a comparable size, appropriate, so it must be comparable to the size wavelength of the light, then only it absorb the light and re-emit in different direction with a different intensity. It's called scattering of light. And related to colors, related to blue color of the light and during reddish and evening and morning it appears reddish color. So that is related to colors only. That is also related to colors only. Okay, that is also related to colors, related to scattering of light only. Coming to the positions is about atmospheric refraction. Sun appears delay 2 minutes, 2 minutes advance and delayed sunset. This all the reason atmospheric refraction. Related to colors, related to blue color of the sky, white color of the sky in mid time. So sky appears, normally sky appears white during noon time, so around 12 o'clock. Why? So what are the particles are there, at that time, so it will scatter all the light equally in all directions, so all the colors will be mixed, will get as a white light. And so you are seeing the remaining time, so blue color during evening and morning it appears reddish. So related to colors mean, that is the what is the phenomenon involved in it is scattering of light. Okay, related to color, scattering of light. Related to positions, like normally if you are taking stars twinkle, this also atmospheric refraction. So star is somewhere far distance, so keep on atmospheric refraction takes place. Star position does not change because of the atmospheric refraction. We can see the star twinkling. So planets are the minute source of light, so point sources of light. So one it will be bright, one it will be dark, one it will be bright, one place it will be bright, one place it will be dark. So entire effect will be nullified. That is about why planets twinkle, why stars twinkle, why not planets twinkle. Okay, why not planets not twinkling. Okay, why planets are not twinkling? Because so planets are minute sources or point sources of light. So one it will be, so it will reflect the light, so it doesn't have its own light but reflect light. So one it will be one place it will be brighter, one place it will be darker, one place it will be brighter, one place it will be darker. So overall effect will be nullified. So that's the reason planets do not twinkle. So star twinkle due to atmospheric refraction. And one more thing, next one, advanced sunrise and delayed sunset. And coming to the this two and remaining also there. So and here in this case we discussed in the refraction phenomena. So like that. Okay, so that is about atmospheric refraction. The maximum those points only will discuss. Scattering of light also completed. Tyndall effect. The path of the light becomes visible. When it is passing through the colloidal solution. Scattering of light takes place by the colloidal solution. Scattering of light takes place by the colloidal solution. That is the reason. So the path of the light becomes visible. Normally, you can see when you open the window in the morning time. When you open the window in the morning time, so a parallel beam of light falls on it. We can see the dust particles are flying. Even during the rainy time, also near the bulb, you can see the water droplets are flying. So like a small water droplet, not big one. Okay, small, 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 like moisture. And one more thing, so if you're in a forest, if you see a narrow beam of light ray falls, even in the afternoon time also, when you're going, so trees are there. So when you're going in the road, trees are there. So a small beam of light ray falls. It's a narrow beam of light ray falls. That time also we can see the dust particles are flying. Okay. So the scattering, Tyndall effect is nothing but the path of the light becomes visible when it is passing through the colloidal solution. So by the colloidal solution, scattering of light takes place. Then the path of the light becomes visible. The path of the light becomes visible. That is called Tyndall effect. Tyndall effect. Tyndall effect. Okay. So this is about human and colorful world. So maximum points we discussed. If you have any doubts, you can ask. So you can call to this number if you need any classes regarding that. You can call to 9849812804. You can call to this number. Still, if you have any doubts regarding the chapter, regarding remaining chapters also, if you have any doubts, you can contact me through that number. So this is your Siva sir from Student the Brand. If you like this content, if you like this life, if you like my explanation and like the content, so if you like the channel, please do like, share, and subscribe to Student the Brand. And you can so my channel Student the Brand. You can share to your friends, ask them to join to the class. You can share to your friends, ask them to join to the class. So we'll discuss the topics. Okay. So thank you so much for joining. So we'll see you in the next class. So around I'm expecting to take around 3 o'clock. 3 o'clock again class will be there. You can join at the time. So we'll discuss. Thank you so much. See you at 3 o'clock timings. Thank you.